Somewhere in the Arctic Ocean, a Greenland shark is hunting, moving through water just above freezing, slowly, slower than a human walks, nearly blind, 7 meters long, 1,400 kilograms. And it was born around the year 1620. Think about that for a moment. 400 years ago. Shakespeare had been dead only 4 years. The Pilgrims hadn't yet landed at Plymouth Rock. There were no telescopes powerful enough to see the moons of Jupiter. No industrial revolution. No electricity. No cameras. And this shark was born. It grows less than 1 centimeter per year. It didn't reach sexual maturity until it was 150 years old, longer than most humans live. Everything about it is slow, patient, ancient. Radiocarbon dating of eye tissue, which forms before birth and never changes, confirms it. Some Greenland sharks alive today are over 400 years old, the longest-lived vertebrates on Earth. Tonight, we're meeting the giants of the deep, creatures so large, so old, so strange, they defy intuition. Some we've pursued for centuries. Others we discovered only recently. And some we'll return to this we may not have found yet. But first, why does the deep sea produce giants at all? The deep should favor the small. Food is scarce. Energy is precious. Cold water, crushing pressure. Logic says, stay small, stay efficient, survive on almost nothing. The opposite is true. The deep sea is home to the largest invertebrates on Earth. Isopods the size of house cats, squid longer than buses, crabs with leg spans exceeding the height of a room. The answer lies in paradox. The very conditions that make the deep hostile also make it ideal for giants. Cold water slows metabolism. Biochemical reactions happen at a fraction of the rate they do in warm, sunlit seas. And there's a principle. Larger animals are more energy efficient per unit of mass than smaller ones. An elephant uses less energy per kilogram than a mouse. In a food-scarce environment, being large becomes an advantage. You survive longer between meals. You travel farther to find food. Deep-sea isopods can survive years without eating. Their shallow water relatives, pillbugs, survive days. Cold water also holds more dissolved oxygen than warm water. Massive bodies with slow metabolisms can function on what's available. And pressure, which you'd think would limit size, affects only gas-filled spaces. Bodies made of water, muscle, gelatinous tissue, the external pressure is balanced internally. No crushing. Then there's predation. In shallow water, being large makes you a target. Speed matters. Agility matters. In the deep, there are fewer predators, fewer eyes. Being large doesn't make you vulnerable. It makes you safe. And finally, time. Deep-sea organisms live extraordinarily long lives. Growth is slow, but sustained over decades, centuries. Time allows size to accumulate. So, the deep creates giants. Now let's meet them. The largest eyes in nature belong to the giant squid, Architeuthis. Eyes 25 centimeters across, the size of dinner plates, evolved to catch the faintest flicker of bioluminescence, a shrimp's glow, a jellyfish's pulse, in water where no sunlight ever reaches. 13 meters long, tentacles lined with hundreds of suckers, rimmed with sharp edges. The giant squid appears in human records long before science accepted it existed. Norwegian sailors in the 1700s called it kraken. Descriptions were consistent: tentacles rising from the deep, longer than the mast of a ship, wrapping around hulls. Bishop Eric Pontoppidan documented accounts in 1752. He was mocked, dismissed as folklore. But the descriptions were too specific, too detailed. In 1861, a French gunboat encountered a giant squid at the surface off the Canary Islands. The crew tried to capture it, looping rope around its body. The rope cut through. The squid was too heavy. It sank back down, leaving only a portion of tail. They brought the torn fragment back for study. Proof at last that the kraken had a body. Then came Newfoundland, 1873. 2 fishermen and a boy in a small boat. A giant squid surfaced beside them, alive, thrashing. In the struggle, a tentacle separated from the body. The squid retreated. The recovered limb measured 6 meters. The specimen still exists, preserved, catalogued. Proof. By the late 1800s, strandings increased. Dead squid washing up on beaches across the North Atlantic, New Zealand, Japan. Always mangled, always incomplete. Scientists collected beaks, measured tentacles, photographed corpses. But no one had seen one alive, not in its element, not hunting. For over a century, we pursued it. Submarines descended with cameras. Researchers deployed bait at depth. Whale carcasses, lights, lures. Expeditions failed year after year. The problem was light. Standard underwater filming requires bright illumination, and every time lights switched on, the squid vanished. They could detect the glow from hundreds of meters away. In 2012, a team led by Tsunemi Kubodera tried something different. They built a submersible with a dim red light, wavelengths giant squid can't perceive easily. They used a specialized lure called the e-jelly, mimicking the bioluminescent pulses of a jellyfish in distress, a signal that attracts predators. They descended to 630 meters off Japan's Ogasawara Islands, and they waited. Hours passed. Then, movement at the edge of the frame. Tentacles. First 2, then more. The squid approached cautiously, drawn by the lure's pulsing light. It extended feeding tentacles. the two longer appendages used for striking prey, and grabbed the e-jelly. The camera captured it. 8 arms, 2 feeding tentacles, mantle contracting rhythmically, propelling it forward, eyes reflecting the faint red glow, massive, unblinking, watching. It wasn't aggressive. It was curious, investigating. The encounter lasted minutes. Then the squid released the lure and jetted backward, disappearing into darkness. The footage revealed something unexpected. The squid's movements were graceful, controlled. Not the thrashing monster of legend. Something precise, intelligent, adapted perfectly to its environment. 150 years of searching, a few minutes of footage, and still, we know almost nothing. But we know they're hunted. Sperm whales dive thousands of meters to find them, and the evidence is written on their bodies. Circular scars, sucker marks, cover the heads of adult sperm whales. Some scars are startlingly large, suggesting squid far bigger than any we've measured. The whales carry these marks for life, permanent records of battles fought in absolute darkness, at depths where the pressure would crush human lungs. Sperm whales can dive to 2,000 meters, hold their breath for 90 minutes. They use echolocation, clicking sounds that bounce off prey, to hunt in zero visibility. When they find a giant squid, the battle is one-sided. The whale has mass, momentum, teeth designed for gripping. The squid has speed, camouflage, tentacles. It's never enough. We've examined whale stomach contents, found squid beaks, the only part that doesn't digest, by the hundreds. Some beaks are enormous, far larger than any attached to specimens we've recovered. Beaks from squid species we've never identified, species that may be as large as the giant squid, or larger, living deeper, rarer. The whales know where they are. The whales hunt them. We don't even know they exist. There's something even larger. The colossal squid, Mesonicoteuthis, heavier than the giant squid, found only in the deep Antarctic. And instead of suckers alone, its tentacles carry rotating hooks, triple-pointed, not for gripping, for impaling. The largest specimen ever found was hauled up by a fishing boat in 2007, around 10 meters, nearly 500 kilograms, dying when it reached the surface. The crew froze it immediately. There was no way to keep it alive. It's preserved in a New Zealand museum now, pale and ghostly. For decades, no one had ever filmed a living colossal squid. We had one frozen specimen, beaks from whale stomachs. Nothing more. Then, in April 2025, researchers finally captured footage. A juvenile, small, drifting in Antarctic waters, tentacles trailing, hooks visible even at that size. We finally saw one alive. But the adult, the true giant, heavier, larger, descending to depths we can't easily reach, that remains finds a ghost. Not all giants are hunters. Some are scavengers, moving slowly across the seafloor, patient and ancient. The giant isopod, Bathanomus giganteus, looks like a pill bug scaled up 50 times. 1/2 meter long, armored in overlapping plates, eyes still functional despite near total darkness. They crawl through the abyss, searching for anything edible. Whale carcasses, dead fish. One specimen in a Japanese aquarium survived 5 years without eating before it died. 5 years. Then there's the Japanese spider crab, Macrochira kempferi. Legspan up to 4 meters, 12 to 13 feet from tip to tip. Its body is small, but those legs, impossibly long, jointed, moving across the seafloor like something assembled from parts that don't belong together. They live up to 100 years, and they decorate themselves, attaching sponges and anemones to their shells, camouflaging against the mud. Imagine encountering one in darkness, legs emerging from the gloom, longer than your body, reaching. The invertebrates are titans, but they're not the only giants. Some giants drift, some hunt, and some have lived longer than nations. The whale shark, Rhynchodon typus, is the largest fish on Earth. 18 meters, 20 tons, a filter feeder, gentle, swimming with its mouth open to sieve plankton. You might think of whale sharks as surface dwellers, basking in tropical waters, but GPS tracking revealed they dive deep, down to 1,900 meters, into the twilight zone, possibly following the largest migration of animals on Earth. Billions of fish, squid, and krill rising toward the surface at night. And despite decades of study, we still don't know where they mate, where females give birth. Basic questions remain unanswered. The oarfish, Regalicus glesni, is the longest bony fish, 11 meters, possibly more, silver, ribbon-like, with a red dorsal fin running its full length like a crest. They live between 200 and 1,000 meters, rarely seen. When they wash ashore, people panic. Sea serpents, omens. But video captured in 2010 showed the truth. An oarfish swimming vertically, body undulating in slow, mesmerizing waves. Not a monster, just strange, alien. And then there's the Greenland shark we met at the beginning, Somniosus microcephalus, swimming through Arctic waters, moving at 0.3 meters per second, 7 meters long, 1,400 kilograms, and over 400 years old. The oldest Greenland sharks alive today were born around 1620. They've lived through 4 centuries, through the Age of Enlightenment, through the Industrial Revolution, through 2 world wars, through the Space Age. They don't reach sexual maturity until they're 150 years old. They grow less than 1 centimeter per year. Everything about them is slow, patient. Their metabolism is so reduced, it approaches suspended animation. Their flesh is toxic, saturated with trimethylamine oxide, a compound that helps stabilize proteins under pressure, but makes their meat poisonous to most predators. Inuit communities historically buried Greenland shark meat for months to ferment it, breaking down the toxins, producing a delicacy called haukal. Even then, it's described as an acquired taste. Most Greenland sharks are nearly blind. Parasitic copepods, small crustaceans, attached to their eyes, dangling like pale, grotesque ornaments. The parasites feed on the corneal tissue, destroying the shark's vision over time. But in the deep Arctic waters, where they hunt, vision is almost useless anyway. They rely on electroreception, detecting the faint electrical fields generated by muscle contractions in prey. They sense heartbeats in the darkness. They are ambush predators, slow-moving but patient. They've been found with seal remains in their stomachs, entire seals swallowed whole. Some believe they catch seals sleeping at the surface, rising silently from below. Others think they scavenge seal carcasses, maybe both. 4 centuries of existence, moving through cold, dark water, silent, unhurried, ancient in a way that makes human lifetime seem like flickers. These are the giants we know. But here's the question. What haven't we found yet? The ocean covers 361 million square kilometers. Average depth, 3,700 meters. We've mapped about a quarter of the ocean floor to modern standards. The rest is still incomplete or inferred. But we've visually seen less than 0.001% of it. Less than 1,000th of 1%. Every deep-sea expedition finds new species, not just microbes, large organisms. The megamouth shark wasn't discovered until 1976. 3 meters long, over a ton. A filter feeder, unknown to science until a specimen tangled in a ship's anchor. How does something that size go unnoticed? Because the ocean is vast and deep and dark. The giant squid was known for centuries from beach strandings and fishing net accidents. But it wasn't filmed alive until 2012. The colossal squid wasn't filmed until 2025. If creatures that large can remain hidden, what else is down there? Consider patterns. Giant squid exist. Colossal squid exist. Both over 10 meters. Are there other species, equally large, equally elusive, that we simply haven't encountered? A third squid species, deeper still? Or something unrelated entirely? A giant octopus in the Hadal Trenches? A massive eel in the abyssal plains? Gigantism is a clue. Where the deep repeats its rules: cold, pressure, time. it repeats its giants. The deep ocean trenches have been visited more frequently in recent years, but coverage remains sparse. Challenger Deep, the deepest point on Earth, has seen dozens of descents since 2019. But each dive lasts hours and surveys an area roughly the size of a football field. Challenger Deep is a small depression within the Mariana Trench, and the Mariana Trench stretches about 2,550 kilometers long and 69 kilometers wide. Ours. One football field. In a feature larger than the Grand Canyon. The Mariana Trench has received more attention than most, but even there, discoveries challenge assumptions. In 2017, researchers found a snailfish at 8,178 meters, deeper than we thought vertebrates could survive. The pressure at that depth is over 800 times what we experience at sea level. The fish's body is mostly water and gelatinous tissue. No swim bladder. Bones barely calcified. Built to withstand forces that would pulverize most life. And it wasn't alone. Amphipods, shrimp-like crustaceans, were swarming around the bait. Some the size of a human hand. These trenches aren't barren. They're inhabited. The Tonga Trench, second deepest on Earth, visited fewer than 10 times. In 2014, researchers sent down a lander, an unmanned probe, and retrieved samples. They found organisms using biochemical pathways we didn't know existed. Microbes metabolizing compounds that shouldn't support life. And larger creatures, fish, crustaceans, species unknown to science. A handful of dives across decades, then silence. The Philippine Trench, 10,540 meters deep, reached by humans only twice. 2021 was the first time. We've sent unmanned probes to scattered points, retrieved sediment samples, recorded sonar data, but comprehensive observation, we've barely started. What lives there? We don't know. And there are 27 hadal trenches on Earth. Most have never been explored. Then there are the sounds. In 1997, underwater microphones detected something in the Pacific. The bloop. Ultra-low frequency, loud enough to be heard 5,000 kilometers away. Its pattern resembled biological sounds, but indicated something far larger than a blue whale. The mystery was eventually solved. An ice quake. Ice fracturing and calving into the ocean, resonating through water at frequencies that mimicked organic noise. But the bloop reminded us, we can only listen. We cannot see. Other sounds have been recorded, some identified, some still debated. The upsweep, detected since 1991, a continuous sound recorded by hydrophones across the Pacific. Its source remains unresolved, though researchers suspect volcanic or seismic activity. It's been declining in volume over the years, but it persists. Julia and Slowdown were both recorded in the 1990s. Low frequency, massive amplitude, both traced to the Antarctic region. For years, they were mysteries. Now, they're attributed to iceberg grounding events, icebergs scraping against the seafloor, generating sounds that travel thousands of kilometers. Most sounds are eventually explained: icebergs, earthquakes, undersea volcanoes. But the process reminds us the ocean is full of noise. Clicks, pulses, groans, some from whales, some from tectonic shifts. And when we can't identify a sound immediately, we are reminded how little we hear, how little we see. Then there are recent discoveries that defy what we thought possible. In 2020, researchers filmed a Dumbo octopus, Grimpoteuthis, at 7,000 meters in the Java Trench. Octopuses are soft-bodied, lacking the structural support of shells or exoskeletons. They shouldn't survive at depths where pressure exceeds 700 atmospheres. Yet, there it was, small, gelatinous, flapping ear-like fins to propel itself through the abyss. It suggests octopuses have adapted to hadal depths in ways we don't yet understand. And then there's the big fin squid, Magna pinna, first filmed in 1988. Since then, sightings have occurred in multiple ocean basins: Atlantic, Pacific, Indian Ocean, always in deep water, always below 2,000 meters. It's unlike any squid we've studied. Its arms are extraordinarily long, up to 8 meters, and hang straight downward, trailing like cables. They don't bend, don't coil, just hang, perpendicular to the body, with what appear to be sticky filaments running their length. We've caught a few: juveniles, mangled specimens, fragments. But the adult form, the creature in the videos, arms trailing 8 meters into darkness, never captured, never examined. All we have is footage, grainy, distant, showing something that doesn't move like other cephalopods. It drifts, hovers, arms dangling into darkness below, perhaps sensing prey through touch or chemical detection. We don't know what it eats, how it reproduces, how large it truly grows. The videos show us a ghost. The specimens we have don't match what we're seeing. It exists. We filmed it. And the mystery remains. Consider the statistical reality. Each deep-sea dive costs millions. The submersible descends for hours, explores for hours, ascends for hours. It surveys an area the size of a football field, maybe 2 if the pilot is efficient. Then it surfaces. The abyssal plains cover 300 million square kilometers. The hadal trenches add another 100,000 square kilometers of terrain, deeper than 6,000 meters. We've explored a fraction of a fraction. Most of what we know about deep-sea life comes from accidents. Fishing nets that snag something strange, whale stomachs containing unidentified beaks, carcasses washing ashore after storms, their bodies too damaged to classify definitively. We are not conducting a systematic search. We're catching glimpses, fragments. And from those fragments, we found squid with eyes the size of dinner plates, sharks that live 4 centuries, snailfish at depths that should crush them, crabs with legs spanning rooms. Every time we push into new depth bands, size stops behaving the way we expect. What we found suggests what we haven't. The giants we've discovered were all found by chance, or persistence, or both. The ocean has revealed stranger things than we imagined. Tube worms at hydrothermal vents, surviving on sulfur compounds in water hot enough to melt lead. Vampire squid, ejecting glowing clouds of bioluminescent mucus when threatened. Fish with eyes like telescopes, aimed upward to detect shadows of prey against the faint light from above. Each discovery expands the boundaries of what we thought life could do, could tolerate, could become. We're not expecting sea monsters, but we're expecting surprises. The ocean is patient, and it hasn't finished revealing itself. "400 years. That Greenland shark we met at the beginning, born around 1620, is still out there, right now, swimming through Arctic waters, moving slowly, hunting, surviving. It has lived through centuries we can barely imagine, through eras of human history that feel impossibly distant to us. And it continues, patient, ancient, unhurried. And it's not alone. The ocean, right now, is full of giants. Moving through midnight waters, eyes adapted to darkness, bodies built for pressure, lives unfolding at scales we're only beginning to comprehend. Giant squid drifting at 600 meters, tentacles trailing, eyes the size of dinner plates, watching for bioluminescent flickers. Colossal squid in Antarctic depths, rotating hooks ready to strike, heavier than any invertebrate we've measured. Spider crabs with legs spanning rooms, moving across the seafloor like mechanical assemblies. Whale sharks diving to 1,900 meters, following migrations we're only starting to understand. Some we've seen once, some we've never seen, and some we don't even know they're there yet. The ocean is vast. Its giants remain, mostly, mysteries. But every now and then, we get a glimpse. A shark that's been alive for 400 years. A squid with eyes built to see single photons. A crab with legs that stretch forever. And we realize the deep doesn't just hide giants. It creates them, nurtures them, allows them to grow to sizes and ages that defy everything we thought was possible. The ocean surface looks calm. Beneath it, right now, 4 centuries of shark, decades of squid, lifetimes measured in timescales we can barely comprehend. The giants are down there, moving, hunting, surviving, mostly unseen, mostly unknown. But there,